Myself Dr.A.Vaniprabha, Professor, EC Department, SNS College of Engineering. Today, we are going to discuss about basic concepts of signals and systems. In the previous lecture, we were discussing about the signal system, the classification of signals and systems. In this lecture, let us discuss on one category of the signal, energy and power. Any kind of signal, whatever we consider as a nature signal also, all these falls under one category, any one category, like either it is energy signal or power signal. How a signal can be decided to be an energy signal? Just by simply understanding the behavior of the signal or through mathematical calculation? Yes, of course, any proven statement is done only through mathematical procedures. Here, a signal is said to be an energy signal if the calculation of the energy signal E is greater than 0 and less than infinite. Then the finite value represents the signal to be an energy signal. For a continuous time signal, energy is found from the formula limit t tends to infinite integral minus t2 plus t x of t mod square dt. That value should be less than infinite so as to be an energy signal. The same case for power signal too. A signal is said to be a power signal if and only if the power value P is greater than 0 and less than infinity. P should be a finite value and should be non-zero. So this is the pictorial representation of an energy signal and power signal. The sinusoidal signal is an energy signal, whereas the linear wave represents a power signal. Energy and power signals. As the classification of signal is defined as continuous time and discrete time, the continuous time signal considered to be x of t. So as to find the energy of the given signal x of t, E is equal to minus infinite to plus infinite x of t mod square dt, or minus infinite to plus infinite x square of t dt must be less than infinity. If it is so, then the given signal is an energy signal. The same case for the power signal also. Limit t tends to infinite 1 by t integral minus t2 plus t x square of t dt. So if this integral is less than infinite, then the signal is said to be a power signal. So in both the case, for a signal to be energy signal, energy should be non-zero, E value should be non-zero and it should be less than infinite. Same way, power should be non-zero and it should be less than infinite. If the given signal is a discrete time signal, it is x of n, then the energy and power shall be calculated using the summation formula. E is equal to summation minus infinite to plus infinite x square of n. For power, it is slightly different from that of the continuous time signal. There in continuous time signal, the factor was constant was 1 by 2t. Here it is limit n tends to infinite 1 by 2n plus 1 summation n is equal to minus into plus n x square of n. Here also the same condition prevails. Power should be non-zero and it should be less than infinite. P value and also E value should be non-zero and it should be less than infinite. So as to conclude, a given signal is either an energy signal or a power signal. So this is the comparison between energy signal and power signal. So how the nature of the signal is and what are the formulas that are used in calculating the energy signal and power signal for both continuous time and discrete time, and the waveform. All the periodic signals can be termed as an energy signal, whereas the standard signals are called as power signals. The sinusoidal signals which repeats at regular intervals or the unit impulse signals which repeats after regular intervals are called as power signal, whereas the rectangular signal and also the slope signal are termed as energy signal. The important points to remember is, so observe the signal carefully. If it is periodic and infinite duration, then it can be a power signal. So we can easily calculate the power. By simply seeing the waveform, we can immediately get into the calculation for power signal without working for both energy and power. This is a simple way to remember. If the signal is periodic but of finite duration, then it can be an energy signal, hence we can calculate energy. And if the signal is not periodic, then it can be energy signal, hence calculate the energy directly. These are the points to remember so as to calculate energy or power without consuming more time. So this is a simple example for energy signal or power signal, how to calculate the energy for a given signal or a power for a given signal. So the question is given here and we have to apply the formula minus infinite to plus infinite x square of t dt, and after applying the formula we have to compute the integration, substitute the limits, then finally we can achieve a numerical value for the power. Therefore, the signal is said to be a power signal. Hope you understood this session. Thank you for your patience listening. Thank you.